Hi everyone, welcome to what most of you will have as your first online video lesson in a math class. And so I want to give you a couple quick tips here before you start watching the video. Number one, you will want to take notes from the video. Understanding that the video may move more quickly than you want it to, and so you need to make sure you're utilizing the pause button and the rewind button. I may do fewer examples also on a video than I would do in class, because you have the ability to stop, go back, and watch an example again. That way, I don't need to do as many. For those of you who understand it, you'll be able to move on. Those of you who need a little more time, you're able to pause and rewind. So please take advantage of those buttons. All right, we're going to add one more shift today onto our sine and cosine graphs. That shift is going to be an amplitude shift. And an amplitude shift will be in the form, as you see here, y equals a times the sine of theta, where a would be any number multiplied by the sine of theta. And just like we've done with so many other graphs, that number in front refers to a steepness in a linear graph, or a slope, as you may remember. In a lot of other graphs, it refers also to the steepness of the line. In this case, it is going to change the steepness by stretching the graph vertically. That A value is going to represent how far above your center line the graph will go and how far below. That's that word amplitude we talked about on Monday. So if I give you an equation such as y equals 2 sine of theta, the amplitude shift is actually by far the easiest of all our shifts. Because all I'm going to change when I go to do my graph is I'm simply going to, instead of maximizing my graph at 1, it's going to have a maximum of 2. Instead of a minimum at -1, it's going to have a minimum at -2. The rest of my graph is going to remain the same, where I have my 5 critical points, and I mark my starting point and my ending point, and I mark my max and my min. Now I'm ready to sketch in my graph. It's sine, so it'll start in the middle. It'll max out at pi over 2, or 90 degrees. There's our change. It's maxing out at 2 instead of at 1, because that 2 is simply a multiplier. If our old max was 1, our new max would be 2 times that, which would be 2. Our min is at -2 when we get back to the 0. So now you can draw in your sine curve, and there you have the graph of y equals 2 times the sine of theta. Like I said, it's a very simple, basic shift. Now we're going to move on to what happens if that amplitude, that number in front, is negative. And if you think about an example we've done many times in this class, a quadratic equation with a negative coefficient, that -2 took our parabola that traditionally looked like this, and it flipped it upside down. That's what the negative did, and the 2 made it steeper, so therefore it went down and was twice as steep. That same exact idea works with a negative amplitude when we're talking about sine and cosine. We already talked about how the 3 will make it 3 times taller, or 3 times steeper. What the negative does is it actually flips our graph upside down. So when I go to draw this, we're going to have a max at 3 and a min at -3. That's the same as if it were a positive 3. The negative does not change the max and min values at all. It does not change how we graph the rest of the function as far as our midpoints or our critical points go. Everything is going to be the same. Now when I go to draw the graph, I know it's a cosine function, and cosine normally looks like this. It goes top, middle, bottom, middle, top. That's your traditional cosine function. What happens when it becomes a negative is this. Instead of starting up here at 1, we've got to start down here. I'm sorry, at 3, we start down there at -3. That's what the negative does, is it flips our graph upside down. So in green here, you will see the actual graph of y equals -3 times the cosine of theta, because the graph needs to flip upside down, because that's what the negative in front does to our graph, is it flips it upside down. So make sure when you're adding this in your notes, the green line is the correct solution. The red line was our original cosine function. The negative gets flipped upside down, so it looks like the green line. Our final example is going to put all three shifts together. We learned about horizontal and vertical shifts on Monday. We're going to combine those with an amplitude shift, like the equation you see here. When you look at a complex equation, we're going to do all that same information that we put down on Monday when we get to these more complex ones. When you have more than one shift, we said we wanted to make sure we were listing out all the information we needed to draw our graph. The 6 pieces of information we're going to use do not change from what we did Monday. The starting point is still going to be the opposite of what is in the parentheses with theta. Your period, we have not discussed period shifts yet. That will come tomorrow. So your period will always be 2 pi today. And your ending point, just like we did on Monday, is your period plus your starting point. So we get -5 pi over 6 plus 2 pi. And we use our common denominators. 2 pi is the same as 12 pi over 6. -5 plus 12 is 7. So I get 7 pi over 6 for the ending point. The center line, we have a vertical shift of -3, so my center line has been moved down 3. And finally, we have to consider the amplitude in order to do the max and min. My amplitude of -2 tells me my max is going to be 2 above my center line. My min is going to be 2 below my center line. So I've got a max at -1 and a min at -5. So now I have enough information to be able to sketch this graph. And so I'm going to scroll down here with the purpose being I don't need the equation in order to do my graph. I don't need to have y equals -2 sine of theta plus 5 pi over 6 minus 3 in order to be able to do my graph. All the information I need is right here. You notice now I've drawn your axes, and recognize that the way the axes were drawn, like we talked about yesterday, reflects the information we have on our graph. My starting point is at -5 pi over 6, so I had to move my y-axis more towards the center of my graph. And because my center line, max, and min were all negative, I drew my x-axis up very high in the graph because I know my graph is not going to go into the negatives. So let's go ahead and sketch our graph by putting all the information we found here on this. We have -5 pi over 6 and 7 pi over 6. And we talked on Monday how I'm not too picky about your respect to 0. As long as your axis is in between the negatives and positives, I'm not going to get too picky about the spacing on your graphs for right now. We want to make sure we're getting the correct information on the graph. We need to find our middle points. Our middle points are going to be in the middle of -5 pi over 6 and 7 pi over 6. We add them together and divide by 2, giving 1 pi over 6. Halfway between -5 pi over 6 and 1 pi over 6, you add them together and you get 4 pi over 6. Half of that is 2 pi over 6, which is pi over 3, and that was negative. And our final middle point is going to be 1 pi over 6 plus 7 pi over 6, which is 8 pi over 6. I divide that by 2 and get 4 pi over 6, which is 2 pi over 3. Now I need to draw in my y-axis, my y labels, -1, 2, 3, 4, 5. I can draw in my box. My max was at -1, center line at -3, and minimum at -5. Remember, the box makes graphing easy. It allows us to draw in the rest of our graph without having to do a lot of thinking. The only piece I have to remember now is my original equation was a sine equation, and there was a -2 in front. And so the negative means my sine is going to flip upside down. So I start in the middle. Normally, sine goes from middle to top. Because it's negative, I'm going to go from middle to bottom to middle, that's the wrong spot, to middle to top to middle. So we have that same sine graph as we did on Monday, except it's flipped upside down. Hopefully you do a little better job of hitting your dots than I did. So this is your first video lesson. Hopefully you're able to follow the information. If there's anything you're not sure about, go back, look at the previous parts of the video, ask those around you, and you'll have the rest of the period here to work on some practice to make sure you've got graphing down so we can add our last shift tomorrow.